Hi everyone, welcome to our presentation. Today I'm going to present our research work on detecting compromised and attack-owned websites. My name is Mohamed Nabeel. This is a joint work with QCRI, Scolab, and University of Colombo. As you probably know, millions of users are exposed to malicious websites every day created by internet miscreants. In this figure, we show the number of unique malicious URLs that we observe from VirusTotal, which is a publicly available URL scanning service, which aggregates threat intelligence from about 70 antivirus engines. On average, we see around 270K unique malicious URLs per week, which is a quite large number. In this research, the key question that we answer is how these malicious websites, these 270K odd websites are hosted. Broadly speaking, these malicious websites are either compromised or attacker-owned. Let me explain what I meant by that. The figure in the left side shows an attacker-owned website, which was maliciously registered by an attacker and then used to launch an attack, in this case, to impersonate PayPal. The figure on the right side, on the other hand, is a benign domain, benign website, which is supplying software for schools. And it was later compromised by an attacker by creating a subdomain called AAA. You may wonder why it is important to distinguish these different malicious hosting types. Let me provide you some key use cases. One, different intermediaries in the internet domain ecosystem are likely to take different mitigation actions depending on the hosting type. For example, if it is a compromised domain, it's likely the domain owner or the web hosting provider take actions. On the other hand, if it is an attack domain, it's likely registrars and registries take action. And it also helps us to impose fine-grained blocking with minimal collateral damage. For example, if it is a compromised domain, in order to reduce the damage that we may cause by blocking that, one may want to block at the level of subdomain instead of at apex level. Finally, being able to detect compromised domains help us to build better reputation systems. We explored all the major blacklists out there to see which ones are reporting the hosting types, including VirusTotal, FishTank, and Google Safe Browsing. Even though this piece of information is quite useful in practice, none of these major blacklists are reporting this information. The current industry best practice is to come up with heuristics or rules that helps them to extract either compromised or attack domains, which we show in the paper results in high false positives and negatives. We take a systematic approach to classify these hosting types. First, we categorize these malicious URLs into either private or public domains. The key difference here is the ownership. If the owner of the website and the owner of the apex domains are the same, we mark them as private. For example, in this case, NSA.gov and all the subdomains are going to be private. On the other hand, if the owner of the website and the owner of the apex domain are different, we mark them as public domain. Broadly speaking, all web hosting services, CDNs, blogs, dynamic DNS domains fall under this category. We then further categorize them into either compromised or attacker-owned. The key difference between the public and private here is we categorize at subdomain level, we categorize at apex level domain for private domains. Now we are going to show you the machine learning pipeline that we designed to detect these malicious types given the malicious URLs. We use VirusTotal feed as our input data, mainly because it's by far the largest malicious website repo out there. So we pass these VirusTotal URLs through our VT report parser, which profiles these domains or websites to build what we call the newly observed domains and newly observed hosts. So it builds a time series for each domain. Following the recommendations from previous research, now we select a subset of report from these past URLs. Specifically, we select those reports which are detected by at least 5 antivirus engines as malicious URLs for our downstream classifiers. We build a ground truth of public and private domains and then train this classifier. And this classifier labels the URLs as either public or private. And then we train two separate compromise attack classifiers to further classify them as compromised or attack owned. So in summary, we input malicious URLs into the system and the system labels them using one of these four classes. Our main data source comes from VirusTotal, and we also utilize fish tank and GSB as well. Our study period is from August 2019 to November 2019, which is roughly 5 months. We collected roughly 800 million unique URLs from VirusTotal. And then also we created two different data sets, which are months apart from the same data set. And as you can see from this table, we have millions of malicious URLs, and they boil down to around hundreds of thousands of malicious apexes. Now we are going to briefly present the two classifiers we built. First, the public-private classifier, which marks given URL as hosted on a public apex or a private apex. You may wonder why we need such a classifier. Can't we rely on existing public suffix lists, for example? What we found was they only cover roughly about 20% of public domains out there. So this is a good use case for machine learning. We can learn the patterns of these already available public domains and try to identify domains which have similar patterns. That's exactly what we do here. We take advantage of subdomain diversity and the variations in the volume and of scans to design features which are presented in the paper. Then we train a model using these features, and we observe that random forests perform best compared to all the classifiers we tried. As the figure in the left shows, our models perform consistently across the two data sets, indicating that our features are generalizable. Next, we briefly touch on compromised versus attacker-owned classifier, where we mark given public or a private URL as one of these classes. And we utilize the deviations in the hosting infrastructure and the differences in lexical formation of URLs, and also scan diversity to design features. And similar to the previous case, our trained classifiers perform consistently well across the two data sets here. And more details are available in the paper. Based on our trained classifiers, we assign one of the four labels to each of the URLs, malicious URLs in our data set. And now we are going to present some high-level findings from that. And this figure shows the distribution of public to private websites that are found in our data set. One interesting observation we make here is even though only 1% of malicious apexes are public, they amount for roughly 50% of malicious websites we see. And this pie chart shows the distribution of compromised and attacker-owned domains. As you can see from the left pie chart, for private malicious domains, nearly 2/3 of websites are compromised, whereas we see, not surprisingly, the opposite trend for public malicious websites. Nearly 80% of these websites are created by the attackers. These statistics highlight the need to have fine-grained blocking mechanism available in order to minimize the collateral damage that I discussed earlier. And also, as a research community, I believe we need to do more in order to protect benign domains, as well as to improve the security posture of public hosting services. Now we show additional properties that we measure on compromised and attacked websites in this work. The left side figure shows the average Alexa rank for compromised and attacker-owned websites during our study period. One interesting observation we make here is the majority, around 60% of the compromised domains are either less popular or not popular at all. One possible reason is these compromised websites have weaker security controls compared to popular ones. The right side figure shows the time gap between the registration and the time at which the first attack happened, as seen from VirusTotal. In the previous research, we have already seen similar trends for the attacker-owned domains. What we would like to highlight here is on the compromised domains. One interesting observation we make here is it's not just the new domains that attackers go after. They, in fact, majority of the time, 80% of the time, they go after domains which are at least 3 years old. This suggests that website owners should continue to protect their websites in order to avoid being compromised repeatedly. We compare our findings against GSB, which is the most popular browser-based defense mechanism available against malicious websites. As you can see from these figures, GSB only covers about 30% of the malicious websites. And more concerningly, they were able to label only about 1% of all the malicious websites. So we believe our models can complement GSB not only to improve the coverage, but also to provide the additional useful information about the hosting types. In conclusions, we showed in this work how to build content agnostic machine learning models to identify various hosting types. Specifically, we identify given a website is hosted on a public apex or a private apex, and also whether it's a compromised domain or an attacker-owned domain. Overall, we see the concerning trend of a majority, 82% of malicious domains being hosted on apexes that attackers do not own. We believe more needs to be done as a research community to secure benign websites and benign domain hosting services. As future work, we plan to implement a continuous evaluation pipeline, an AutoML pipeline, to detect malicious URL types. And also, we would like to integrate our models with existing blacklists and reputation systems. Thank you for listening. If you have any questions, I would be happy to answer now.